Today we talk about some problems related by using truth table and without using truth table. So the very first problem under mathematical logic is construct a truth table for each of the following: P, disjunction Q, disjunction negation P. So first I am going to construct a truth table for the above statement. So let us see how many preposition variables involved in this statement. P, Q. Only two preposition variables, P and Q. If two preposition variables involved, we have only two columns. So P and Q. How many rows we have? 4 rows, because 2 squared, 4 by 2, 2 true followed by 2 false, and second column should follow 1 true followed by 1 false, isn't it? So first we talk about P disjunction Q. P disjunction Q, the truth value of P disjunction Q is, if any one of the truth value of the preposition variable is true, then the disjunction of P and Q is true. Any one of the variable is true, any one of the preposition variable is true, then the truth value of the disjunction is true, otherwise false. So next we talk about negation P. You know that already we know negation P, if P is true, negation P is false. If P is true, negation P is false. If P is false, negation P is true, negation P is true. So and then we can have, this is A and this is B. So here A disjunction B. So once again we have A disjunction B is nothing but what? If any one of the truth value of these two are true, then the value of these two is true, otherwise false. Otherwise false. So this is true. So finally I attained all the truth value of this is true. Therefore this statement is tautology. Tautology. Am I correct? This statement is tautology. So one more example I want to prove. Second one, the second statement is second problem. P conjunction P conditional Q. So once again, how we are going to write the truth table? First you have to check how many preposition variables involved in the statements, P and Q, only two prepositions. So I have two columns, P and Q. So how we are going to write the truth value of this? 2 followed by 2 false and 1 true followed by 1 false, isn't it? Okay. So here P conditional Q. P conditional Q. How we are going to write the truth table for P conditional Q? If P is true, Q is false, then P conditional Q is false, otherwise true. Otherwise true. Isn't it? Otherwise true. Okay, next one, P conjunction P conditional Q. P conjunction P conditional Q, this and this, A and B. So how we are going to write the truth table for this conjunction? Conjunction means if both are true, then only it is true, otherwise false. Both are true, A and B are true, then it is true. Both, this is true, this is false. So false, false, true, false, false, true, false. If both are true, then it is true, otherwise false. So finally I can attain the truth table for P conjunction P conditional Q is true, false. If all the truth values are true, then it is tautology. If all the truth values are false, then it is contradiction. If neither tautology nor contradiction, means this is an example for contingency. Suppose if it is have false, this will gives the contradiction. If all the truth values are true, tautology. If all the truth values are false, contradiction. Neither true nor false means contingency, isn't it? Okay, next example I am going to solve without using truth table. Okay, the first example, without using truth table, prove the following, or we can call it as using laws of logic. You have to prove the following: P conjunction Q conditional P disjunction Q is a tautology. So what you are going to prove? P conditional Q is tautology. P conjunction Q, this is also same as P conjunction Q logically imply P disjunction Q is a tautology. That means we are finally are going to prove is a tautology. Finally you are going to prove that P conjunction Q conditional P disjunction Q is equivalent to true. Logically equivalence to true. Tautology means final answer must be true. Okay. So first I am going to use the left hand side. P conjunction Q conditional P union Q. This is logically equivalence to. So already we know that logical equivalence P conditional Q is logically equivalence to negation P union Q. So this one comes under logical equivalence. So I can apply this, the whole thing I can call it as P and this is Q. Negation P means negation of P conjunction Q union P union Q. Okay, in the bracket you can write logical equivalence. P conditional Q is logically equivalence to negation P union Q. Okay, this is also same as. So here I can apply De Morgan's law. So what is De Morgan's law? Negation P conjunction Q. So for this I am going to apply De Morgan's law. Negation P conjunction Q is negation P union negation Q union P disjunction Q. Here I am going to apply De Morgan's law. This is also same as, see here all connectives are same. So I am going to apply associative law. So what is associative law? Negation P union negation Q union P union Q. Here I am going to apply associative law. So this is also same as negation P union negation Q union P. Once again I am going to apply same associative. Negation P union negation Q. This is also same as negation P union. Here I am going to apply commutative law. P union negation Q union Q. So I am going to apply commutative law. Commutative means A union B equal to B union A, or A intersection B equal to B intersection A. That is commutative law. So once again we have the same symbol. So I can apply associative. Negation P union P. First you can apply negation Q union Q. So I am going to apply associative. Negation Q union Q. So here I am going to apply complement law. So what is complement law? Complement law is nothing but negation P disjunction P is equivalent to true. Okay, negation P union negation Q union Q is true. So I can apply complement law. So P union T, that is dominant law. I am going to apply dominant law. Dominant law is nothing but what? Dominant law is nothing but P union true is equivalence to true. Okay, so this is equivalent to true. So once again I am going to apply null, that is dominant law. Negation P union true is true. Once again I am going to apply dominant. Likewise, we are going to prove the results.